Hello everyone, welcome to this lesson. We are now ready to construct a confidence interval. That will be the main focus of this lesson. As you can see, one of the learning objectives is to construct a confidence interval for a mean. And we're going to be using the t-distribution. I'm going to be introducing you to that distribution in this lesson. Then again, our goal is to be able to interpret a confidence interval using the context of the situation. And our last goal for the lesson is to explain how the sample size and the confidence level can impact the width of a confidence interval. Let's start by first talking about how we can construct a confidence interval. We can construct a confidence interval using the following: x bar minus the margin of error, comma, x bar plus the margin of error. Here I'm giving you the formula for the margin of error. So let's talk about this formula. The formula states that you're going to take the c-score corresponding to alpha divided by 2 times sigma divided by the square root of n. Now, let me help you visualize why we're using that formula. If we want to construct a confidence interval for a mean, we can use the sampling distribution, the x-bar distribution, assuming that it follows a normal distribution by the central limit theorem. Now, the c-score here is going to tell you how many standard deviations, right? A c-score is the number of standard deviations. So that c-score is going to be the number of standard deviations you're wanting to be away from the mean, away from the center. Okay? That is going to be your c-score. You can express that c-score as a positive or negative. That c-score is going to be determined by the confidence level. For example, if your confidence level is 90%, then you're going to want to capture the middle 90% of the area under the curve. So that is how you're deciding what your c-score is. Once you know how many standard deviation away from the mean you want to be, once you know that c-score, then you're going to say multiply that c-score times the standard deviation. That will give you the c-score that will capture that area equivalent to the confidence level. Okay? So that is where the formula is coming from. This is the formula for the margin of error. Now here's the problem. In practice, we rarely know the population standard deviation. Notice that this formula is going to require you to know sigma, which is the population standard deviation. Think about it. We're using a confidence interval to estimate mu, the mean of the population. So we don't know what the mean of the population is. If we don't know the mean of the population, we're likely not going to know the population standard deviation. Okay, so that is the problem that we're running into. If we do not know sigma, how are we going to calculate this part here, sigma divided by the square root of n? The first thing that might come to mind is, well, we don't know the population standard deviation, but we do have the standard deviation of the sample. We do have S. Can we use S instead of sigma? So going back to our formula. Again, the question is, can I go ahead and use S instead of sigma here? The answer to this question is yes. However, if you're going to use S, you're going to be using a different distribution. You're no longer going to be using the sampling distribution, which is a normal distribution. We're not going to be using c-scores. Instead, we're going to be using a t-score. So we're going to be calculating the error, the margin of error, using t times s divided by the square root of n. So now, let me introduce you to the t-distribution. This is also known as the student's t-distribution. This distribution was discovered by William Gossett. At the time William Gossett published this idea about the t-distribution, he was working under an employer. His employer required him to use a pseudonym, and so he chose the name student. That is why the distribution is known as the student's t-distribution. We have a theorem here. If the following conditions are met, if you have a random sample size n, the distribution of the random variable is normal, or the sample size is over 30, then the distribution of t-scores, which are calculated using x bar minus mu divided by s over the square root of n, this distribution is going to follow the t-distribution with n minus 1 degrees of freedom. Okay, so now let me show you how that distribution looks like. Let's look at the properties of the t-distribution. The curve of the t-distribution is similar to the standard normal curve. That is the standard normal distribution. It is also going to be a bell shape, and it's also going to be centered at 0, just like the standard normal distribution. Now, that 0 at the middle represents the t-score equal to 0. Okay. Now, there's a difference between the standard normal distribution and the t-distribution. The t-distribution has more area on the tails. So again, they are similar, but they're not the same. As the number of degrees of freedom, that is n-1, as that value increases, the t-distribution is going to approach the standard normal distribution. And that is what we see on the visual here on the right. Notice, here we see the standard normal distribution at the very top. Notice that the standard normal distribution has less area on the tails. In this image, we also have two other distributions. These are t-distributions. One of them is a t-distribution with degrees of freedom equal to 40. And then we see a t-distribution with degrees of freedom equal to 100. Notice, the t-distribution with degrees of freedom equal to 100, it's a bit more similar to the standard normal distribution than the distribution with degrees of freedom equal to 40. Here we're saying if the number of degrees of freedom increases, we're going to see that the t-distribution approaches the standard normal distribution. It gets closer and closer to the standard normal distribution. Okay? So again, when we're constructing a confidence interval, we're now going to have the value of sigma, so we're going to need to use S, the standard deviation of the sample, and we're going to need to use t-scores. Okay? So let me give you the main steps we take to construct a confidence interval. First, I recommend that you read the given information and label the following: X bar, S, N, and CL. Remember, X bar is the sample mean, S is the sample standard deviation, N is the sample size, and CL is the confidence level. So once you identify those, then you're ready to move forward towards finding the t-score. And I want to go into more detail about the t-score. The t-score is going to be determined by the confidence level. Let's go ahead and take, for example, the confidence level, CL, equal to 0.90. In this case, we would be constructing a confidence interval using a confidence level of 90%. Here, we always have to write that percentage as a proportion. Okay, so I'm writing the confidence level is equal to 0.90. If CL is equal to 0.9, then what is alpha? Well, alpha is equal to 1 minus CL, so 1 minus 0.90, which is equal to 0.10. So what are you trying to do? You're trying to find the t-score. It can be the t-score here on the left or here on the right. They're going to be the same value. It's just that one is going to be negative, the one on the left, and the one on the right is going to be positive, but they're going to be the same value. So you're trying to find those t-scores such that you capture the middle 90% of the area. Again, we don't write this as a percentage, we write it as a proportion. So we're saying we want to capture 0.90 of the area here in the middle. To find this t-score, we're going to need the area to the left of that t-score. Okay? So we need to know what the area here on the left is. Now, alpha, which is 0.10 in our example here, is going to be the area on both of the tails, the tail on the left and right. If I want the area on one of the tails, what do I have to do? Well, I need to take alpha and I need to divide it by 2. You're always going to need to take alpha. You're always going to be dividing it by 2. In this case, we have 0.10 divided by 2. This is equal to 0.05. And now you have the area of both of the tails. Okay. Again, using technology, we're going to be using the inverse of the t-distribution. That function on your calculator, Google Sheets, or Excel is going to ask you for the area to the left of the t-score you're trying to find. And it's also going to ask you for the degrees of freedom. Okay. So in this case, you would say the area to the left of the z-score you're trying to find is 0.05. Okay? Now, you could also find the t-score here on the right, but if you're going to find that t-score here on the right, you're going to need to provide the area to the left of this t-score. In that case, the area to the left of this t-score is going to be 0.95. Okay, I would add those values here. 0.90 plus 0.05. So it doesn't matter which t-score you find. I usually stick to finding the t-score here on the left. The area to the left is always going to be alpha divided by 2. This is the hardest part of constructing a confidence interval, finding the t-value, finding the t-score. Okay? Once you have that t-score, then you're ready to find the margin of error. The margin of error is going to be equal to the t-score that you just found in step 2. That is the t-score corresponding to alpha divided by 2. You're going to have that value, and then you're going to multiply it by s divided by the square root of n. Okay? S is going to be given to you, and n is going to be given to you. Okay? Once you have that value, then you have the error. How do we construct a confidence interval? We just take x bar minus the error, comma, x bar plus the error. Okay? Now, the last step is to write a sentence that interprets the confidence interval, and you always need to use the context of the situation. We can say something like, we estimate with blank percent. This would be the confidence level. So we estimate with this percentage of confidence that the true population mean, right? We're trying to estimate what the population mean is, and we would describe what the population mean is using the context of the situation. And then we would say that this is between blank and blank, and then we would include the units. Those blank spots here at the end are going to be the values that you get from the confidence interval. Okay? So the first value is going to be x bar minus e. The second value is going to be x bar plus b. Here's what we're going to do. We're going to practice finding the t-score because that is the hardest part of building a confidence interval. In these two problems, we are given the confidence level and we're given the sample size. That's all we need to find the t-score. Okay? So let's try the first one together. We're going to find the t-score corresponding to a 90% confidence level using the sample size n equal to 45. Okay? So here's what we need to picture. CL is equal to 0.90. Now, what about alpha? What is your alpha value? Well, remember, alpha is always going to be 1 minus CL. In this case, we have 1 minus 0.90. So our alpha value is 0.10. Again, that alpha value is the area on both of the tails. Here, when we're finding the t-score, we need the area on one of the tails. We need to take alpha divided by 2. Here we have 0.10, that's the value of alpha, and we're dividing it by 2. So we're getting 0.05. That is the area on each of the tails, 0.05. At the center of the distribution, we're always going to have 0. Here, on the left, we're trying to find the t-score. It's going to be a negative value. That t-score corresponds to alpha divided by 2. In this case, alpha divided by 2 is 0.05. The area below this t-value, below this t-score, is 0.05. That's all we're saying when we write t corresponding to alpha divided by 2. Okay. Here on the right, we're going to have the t-score. This is going to be the same value, but this is going to be positive. Okay. What I mean by that is that if our t-score here on the left is something like -2, the t-score here on the right is going to be 2. Okay. They're going to be the same value, just one negative and one positive. Again, that is the reason why it doesn't matter which one you find. You just need to find one. So let me erase there because that's not the t-score. Here we have all the information we need to find the t-score. So now let me show you how to find this using technology. If you're using a calculator, you're going to use the distribution IMBT. The distribution is going to ask you for the area to the left of the t-score you're trying to find. The area to the left of the t-score you're trying to find is always going to be alpha divided by 2. In our case, the area is 0.05. Your calculator is also going to ask you for the degrees of freedom. The degrees of freedom is always going to be n, the sample size, minus 1. So here the sample size is 45. We subtract 1, we get 44. Okay? So that is what you're going to be entering on your calculator. Now, if you're using Google Sheets or Excel, you're going to type in equal t.imb on an empty cell. You're going to open a parenthesis. And again, you're going to need to enter the area to the left of the t-score you're trying to find. The area is always going to be alpha divided by 2. In our case, the area is 0.05. And then it's going to ask you for the degrees of freedom. Again, degrees of freedom is n minus 1. So 45 minus 1 is 44. Now, let me show you how to enter this on your calculator in Google Sheets. Remember, we're using the t-distribution. So we need to go under distributions. I'm going to click on second bars. I see the list of all the distributions. On my calculator, option number 4 is IMBT. So I'm going to go down and I'm going to click enter. You notice it's asking me for the area to the left of the t-score I'm trying to find. We have 0.05. The degrees of freedom is 44. Press enter. I'm going to press enter again. And that is your t-score, negative 1.68022992. Now let me show you how to do this on Google Sheets. On the empty cell, you need to enter equal t.inv. It's going to be this option here. You can click on the option or you can simply open a parenthesis. Now you need to state the area to the left of the t-score you're trying to find. And then you need to type in the degrees of freedom. Close the parenthesis and press enter. Now, one thing that you're going to notice with Excel is that it gives you a few more values after the decimal compared to the calculator. Those values are far away from our decimal point, so they're not going to make a difference. Coming back to our notes, make sure to write the value that you got for the t-score. Here, I just went ahead and wrote the value that we got with the calculator. Okay? Now, I want you to try this on your own. Go ahead and find the t-score corresponding to a 95% confidence level and a sample size equal to 78. Again, I recommend that you use the visual that we have here on the right to help you visualize the area to the left of the t-score you're trying to find.